So with that, Jeffrey, over to you, and thank you so much.
Thank you very much. I first want to give a congratulations to Dr. Roper and the entire program that he put together with Agility Prime. Also the fact that Jay Dreyer, as well as PK, came in support to this, because I think the core topic that the Autonomy Institute is interested in is all about the topics that were discussed quite a bit today, which are about the infrastructure that has to be deployed to support all these new and exciting technologies. So I'm Jeff DeCoux, basically chairman of the Autonomy Institute, which is a consortium of governments, academia, and industry partners coming together to solve the complex challenges. And really, it mirrors the discussion that Jay Dreyer was speaking of, which is it has to be a collaborative environment for us to be successful. I'm just going to share a couple slides about kind of setting context about how the Autonomy Institute came about, but more importantly, get into the questions from the audience, hopefully. So I'm going to share screen real quick. So I kind of made a little custom screen for the Air Force specifically, but when there was a long history about the individuals involved with the Autonomy Institute, our pursuit and how we got here. But one thing that we came about conclusively is that there was a missing infrastructure that would allow any system, whether it be even autonomous cars and trucks and shuttles and rovers and low altitude drones. There was a commonality to infrastructure that was missing and had to be addressed. And the challenge was way too big for industry to try to tackle on their own. So the Autonomy Institute was stood up to really focus on one core topic, which is path to commercialization. There's billions of dollars being invested into autonomy, whether it be the urban air mobility initiatives that were spoken about today, all these vertical flight. But then on the other side, there's a tremendous amount, billions of dollars being put into autonomous cars and trucks and rovers and other forms of transport. But all of them are missing the fundamental piece that I think is now being acknowledged at scale, which is what is the infrastructure that has to be adopted to allow this to scale. And to Jay Dreyer's point, industry can't do it alone, and government needs collaboration of industry. And there's a tremendous amount of research and a lot more studies that have to be done with conclusive data being captured at scale. So the Autonomy Institute, if there's four core themes, it's establishing infrastructure within what we call autonomous mobility corridors and allowing that testing to take place, mainly driven by research and universities and working in collaboration with NASA and MITRE and other research bodies, and then transitioning that research to legislative and policy holders that can actually make decisions with data that's captured at enough volume and enough precision that really hard decisions can be made about how this technology can be adopted into a commercial environment. So it's, there's been a lot of consortiums that have been talked about and developed over the years. What we patterned after is in spending time with Admiral Inman, which was the pioneer of actually the first consortium after the antitrust laws were resolved in the early 80s. Admiral Inman established MCC and Semitech to address at that time the competitive threats of the Japanese. They were actually out innovating many on the electronic components, and the MCC and Semitech were developed. We see a similar, well, actually much larger. He said this is 10, if not 100 times larger than the threats that we had back then, in that the complexities and the opportunities of autonomy in general, the productivity gains, the massive impact it's going to have on society, had to have this more grand approach on pulling in partners. How that comes about, this slide kind of shows that the Autonomy Institute is seen more, think of it as more of a catalyst, just an injection of fuel into the engine to pull in industry and pull in government into test grounds at universities first starting at these autonomous infrastructure labs. We're working with a number of universities to establish these test grounds for 24/7 testing, not just showing up at a base one day, doing a couple days of testing, pack up and leave, but how are they going to be put in production? That means 24/7 testing has to take place. And University of Texas Austin is really leading the way with the J.J. Pickle Research Facility, and the director there is Dr. Hebner, and he's done an exceptional job leading the efforts for the university. But we also see leadership from TMD, Texas Military at Camp Mabry, at Rutledge campus, which is Texas A&M, and it's expanding to other universities. What that allows us to do is do testing and expand across what we call a zone or a corridor. And here in Austin, we've already defined a corridor between the 400-acre property at J.J. Pickle and the 350-acre property at Camp Mabry. And I'm bridging that together with all the needed infrastructure to allow autonomy to take place. And when we're talking about these tests, we're not talking about everything just flying, and we're mainly focused on the 400 feet on down, and that it's a common infrastructure on how the system will be used. My apology for that ringing. That'll move into the city of Austin, and several other cities in Texas are highly engaged in supporting. And then the goal is to get the critical data, because everything that allows decisions to be made at the government level starts with data. And we're never going to be able to get data unless we have something that can be expanded and performed routinely at volume to allow that to drive decisions. And the goal there is the more data we can capture, the more resilience we can actually demonstrate, the faster we will have a path to commerce. We use this slide to kind of describe, when we talk about infrastructure, a lot of people talk about UTM and other systems. And even though UTM is a critical piece, the last 5 years in discussion about UTM, it's all about software. And though I'm from industry, I'm a huge believer that software is eating the world. Unfortunately, software has to run on something. And when we talk about infrastructure, it does not exist anywhere in the world on supporting these systems to be adopted. So just like rail, the locomotive required rails, and cars required roads, and with the FAA, which is the most complex system of systems we have in the United States, operating transponders and radars and ground-based GPS, space-based satellites, tremendous amount of antennas, all working in concert with each other to support a resilient, safe, and reliable commercial airline, as well as military-based. Same thing with data centers. We all take internet for granted, but if it wasn't for the infrastructure that was really pioneered by DoD, and then of course industry picked it up and ran with it, we wouldn't have the internet that we take for granted today. And if you think about any form of autonomy being adopted in our cities or suburban areas, and you say, what point to the infrastructure that's deployed to support that, it is zero. I mean, we've worked with a large number of the DOT agencies across the United States and federal regulators, federal agencies, and it's clear that there's a gigantic hole missing if we're going to see any of these technologies transitioned. And to kind of point out some obvious things is, in a city, when you think about something being adopted at scale and basically being engaged in supporting, whether it be an autonomous shuttle driving down the road, delivering us, a Uber ride from one building to another, or transitioning to a drone delivering some pizza to you, or autonomous cars driving around the city, or transport trucks going between cities, all types of signals have to be there, all types of infrastructure has to be there, and they have to work in collaboration. And this is probably the image that kind of describes the best picture of the number of signals. You think about GPS and RTK. You think about 5.9 gigahertz when you think about vehicles on the ground. But all that has to work in concert with each other to effectively allow any of these technologies to be transition to commerce and supported by the US government as well as industry. So that's the kind of your best overview. I'll leave you with this image up, and then I'd love to go to questions.
Great, thank you so much, Jeffrey. So we just have a couple questions, and then audience, if you could please keep chatting them in. But the first one, Jeffrey, is many of us are hardware people coming from a radio control hobby background. We build airplanes, not electronics. How do small startups approach the big industry leaders for help with electronics, autopilots, and autonomy?
Well, I think the last 5 years, I would say that industry or that perspective has been embraced at scale. And I'm excited for the systems being transitioned and new aircraft being built and new autopilots coming to market. But we're at a stalemate now. I mean, unless we get infrastructure deployed to support this, we're not going to be able to see those systems expand and really start a gigantic renaissance of technologies that are actually in effect impacting people's daily lives. So I'd say that we're heavily dependent right now on addressing the fundamental infrastructure that allows more robust testing to take place with even the smaller units.
Great, thanks. The next question from the audience: what support do you need from federal, state, and local governments?
Basically, just what we've been doing with the universities is just alignment and collaboration, and we've started an agreement that allows the local government, like here in Austin. It's not easy to do this because you can't just go to the university, set up an operation, and go ahead and start testing. You have to have the city embracing it. You have to have the community embracing it. You have to have the states supporting it. So I think that the main thing is for the other regions that we're looking to expand to is just reaching out and saying that there's interest and there's a willingness to collaborate and pull the effective partners that have to be at the table to push things forward.
Great. All right, the next one. Completely agree on the infrastructure piece. And what about military applications for resupply, personnel rescue, etc. within the third world? We can't count on infrastructure in the third world. Is the answer putting some of this into a space-based solution?
100%. So if we go back to the original slide, we kind of had some Easter eggs in there. In this slide, you'll see in the upper right corner, there's a lot of new satellite systems that are already launched and are being launched. So companies like OneWeb and Kepler, and of course the one that we recognize the most, SpaceX, with their Starlink program. But the other thing that I point out is that a general said when we were in a meeting, when someone said, well, we can't think about infrastructure being in theater. And lo and behold, when we go into theater, there's a tremendous amount of infrastructure that's deployed ahead of the line. So to think about infrastructure that can be deployed off of the back of the C-130 is a very natural inclination that the DoD has going into facilities.
Follow-up question on that. Do you think the upcoming 5G network will solve some of these issues?
Well, the infrastructure, if you see in the middle of the screen, we call it the public infrastructure network node. That one little device supports the 5G, the ITS, which is intelligent transportation systems, as well as the edge computing technology that is required to support that deployment. The problem is if anybody realizes, China already has 60 cities lit up with 5G. They already have 110 million users on 5G. We have very, very small pockets of 5G deployed in the United States, and we're at best, 2 years behind. And that's because it costs a lot of money to get this infrastructure pushed out. What we found is we've collaborated now with the very large banks, the Morgans, the Macquaries, the the Goldman Sachs and all these other infrastructure investors on how can P3s be funded to support a consolidation of technology. So if you consolidate ITS technology and 5G and edge computing into a single deployment, now you're dealing with 3 deep pockets to pay for the deployment.
Great, thank you. For smaller delivery drones, how do you see the infrastructure landing pads looking like? Battery swapping or wireless charging?
Potentially neither. I think battery swapping is a horrible idea, in my opinion. So I think it's far easier to have a number of drones that does delivery. But I think there's some applications that battery swapping will have to take place on like trucks that are out there delivering a lot of packages in a single day. But we're more focused on rapid charging, which doesn't necessarily have to be wireless. It could be, contact to contact, copper and copper.
Thank you. Okay, how can an autonomous vehicle fly VFR and conduct see and avoid when there is no pilot?
Well, with the infrastructure, if you look back at the slide, there's one thing in the middle here, that we try to highlight, which is non-cooperative. So as much as the automotive industry, which is the most pioneering and saying that they're close to level 5 autonomy, and that's primarily because they started that whole grand challenge under DARPA's leadership. It's all about sensors on the car. And I don't care how many sensors you put on the car, there are so many edge cases and things that the car is not going to see. So for the next 10 years, it's going to be how can we solve for non-cooperative to allow even the smallest instances of autonomy to be engaged within the city. So how they can see is there's a tremendous amount of sensors, and I'll just kind of use this slide to kind of talk about it. This slide shows 5G in this mast of this PINN, but there's also cameras. There's RF, spectrum analyzers. There's, vehicle, to infrastructure. There's radars. There's, backhaul, systems. There's many, many devices that component-wise, they're fairly cheap, but they have to be deployed. We have to get them into the physical world for us to be able to support the industry. And that's where you're gonna see multiple feeds of telemetry fed back into the system, fed back into the car, fed back into the drone, so we can successfully see these deployments.
Great, thank you so much, Jeffrey. We have time for just one more question. What are the key collaborative elements for urban air mobility?
The key collaborative elements?
Yep, key collaborative elements for urban air mobility.
For urban air, that's a big one. Urban air is going to be one of the most challenging because you have to have not only the legislative, the policy, you have to have on the VTOLs, you have to have vertical vertiports and a lot heavier infrastructure than we have today. So I think the way we look at the challenge, if you went back 20 years ago and you asked the preponderance of the industry, what would be the first autonomous robot at scale in our society today? Very, very few would say it was a Roomba vacuum. And I think we need to challenge the perspective of what is going to be the first device that allows us to provide resilient testing and basically get to the level of data that allows us to show enough resilience and enough reliability in the system to get to autonomous cars, trucks, and eventually the urban air mobility.
Thanks. All right, that's all the time we have for this round. Thank you, Jeffrey. Thank you, everyone, for your questions. We're now going to have everyone except Jeffrey. Jeffrey will stay here. Everyone else, please leave this meeting, head back to agilityprime.com and join your next breakout. So you're going to click on the next speaker you would like to go see for the second round. So please exit this meeting, head back to agilityprime.com and pick your next breakout. And for everyone who just joined, this round will look exactly like the round you were just in. We'll have you submit questions through the chat which you will find at the bottom of your screen, the chat button. Please submit questions and we'll do some Q&A at the end. Thank you, and Jeffrey, over to you.
Okay, great. Thank you. I appreciate the time of anybody that's joining. I'm Jeff DeCoux with the Autonomy Institute. I appreciate Dr. Roper initiating the Agility Prime. I think it's a fabulous program, and we're looking very encouraged about what that's going to lead to in the near future. I also want to draft off of some of the comments that Jay Dreyer and PK talked about as far as infrastructure, and about how it was going to be an ecosystem play, teaming together to actually solve this, because industry is not going to be able to do it on our own, and governments and academia are going to be really key participants in driving things forward. The main objective of the Autonomy Institute is said right here on the bottom. It's path to commercialization. So I think there's been a lot of pursuits. We've now seen over the last 5 years some, I think, incredible instantiations of autonomy, whether it be through cars, trucks and rovers and drones, and even some early applications of urban air mobility demonstrations. But all those require something that's been fundamentally missing in all the conversations. Even though we have talked about a thing called UTM, UTM has all been in discussion about software, and it's missing the key ingredients of the hardware or the actual physical infrastructure that has to be adopted at scale. So this slide, kind of reiterates what was already said by Jay and PK. Is industry, once again, even though we have spent over the last 10 years close to $100 billion pursuing autonomy and application, and whether it be cars or trucks or delivery systems, we are still very distant from the technology being deployed at scale, and it's going to require a lot more collaboration. And what I point out is, if it wasn't for the government, we wouldn't have the internet today. If it wasn't not for government, we wouldn't have 5G coming to the market today. If it was not for government, we would not even have the grand challenge that led to all these autonomous cars being on the roadway today. So it really requires far more collaboration with government, academia, and industry to pull this off. We kind of summarize the Autonomy Institute as a catalyst. So if you think about it, we are not trying to create new standards, but we are trying to push and pick standards that drive forward. There's already incredible standards bodies in the market. There's already incredible platforms. Like even just thinking about UTM services and some of the more advanced autonomous platforms that are out there today, those come from NASA, like EVA, the architecture from NASA. And the FAA has an incredibly robust system called the SWIM system, which has unbelievable data feeds that can really go to the heart of what we need to understand for these systems to be transitioned at scale. So what our goal is working in concert with establishing labs at universities and other research facilities, is pull in governments along with industry and solve grand challenges together, because many of the times up to 80% of the solution is common, and we need to unify our forces to address that. Of course, DoD is going to go far more advanced on security and resilience, in harsh environments, but many of the fundamentals are the same for the commercial industry. So the way we see it is physical labs have to be established where 24/7 testing is taking place. When I say 24/7, I really mean 24/7. And a good use case we point to is a company called Kiva Robotics. In order for them to cross the chasm and get their algorithms and the control theory working properly and to eventually be acquired by Amazon, they had to have all the little robots inside those facilities operating 24/7. And that allows us to get the most important thing that drives decisions right here in the middle. We talk about data. Right now, MITRE and FAA and DOT, there's no major source of data being pushed in to show the resilience of systems. So the goal is labs, move them into corridors, move it into a larger zone within a city, and push the data that allows decisions to be made by legislators and policy makers. The example we give is just like locomotives required rail and cars required roads, and with the airlines, it required a much more complex, much larger scale deployment of infrastructure, working in as a system of systems to allow that industry to become what it is today. And now we're kind of marrying two worlds together. We all know what the internet has done, and we all take for granted what it allows us to do daily. But now these two worlds, the physical world and this data world, has to come together, but it's still infrastructure that has to be installed to support that. And the infrastructure that's, we found commonality amongst many industry partners and operators is what we call public infrastructure network nodes. Because the challenge is very big. Because if we really want to solve for any form of autonomy to be adopted within a city or even a suburban environment, you have to solve for the non-cooperative activity. And to solve for non-cooperative, that means there has to be a sensor system that is outside the vehicle. And the public infrastructure network nodes, along with the cell towers across cities, can support this new infrastructure that allows that activity to take place. So I'm going to just leave it right here, just kind of showing you an example of what we're doing with the University of Texas, Austin, where they have a 400-acre property, and Dr. Hebner, which has led many efforts for the government over the last 30 years, is leading the effort there to lay down the first large-scale infrastructure that allows testing of these resilient systems and allow this data to be captured. So I'll stop.
I was on mute. Sorry about that. Thank you so much, Jeffrey. Thank you, everyone. Please keep submitting questions as we go. Jeffrey, first question for you from the audience. What sensors are fundamentally required for full flight autonomy?
That's a complex question because it really depends on the application and the size of the vehicle. I'd rather, if I centered it around the infrastructure that's on the ground or in the basically accessing the low altitude airspace, I'll identify a few. We believe radar just as important as it was for the FAA to do the advanced next gen systems they have today. If you think about low altitude, a similar system has to be adopted at scale that tracks ground as well as low altitude flying. There's a tremendous amount of RF systems that have already been tested and used in other industries that will become another sense for telemetry and tracking. And then of course, the wireless networks themselves are going to provide a tremendous amount of servicing and support for APNT, which is assured position, navigation, and timing.
Great, thank you. Next one is LiDAR going to be used, and if so, how?
I think LiDAR, even though I'm not convinced that LiDAR has to be on every single autonomous car that's out there today. I do think it's an important sensor, but also I think we have to think about the end goal is having multiple sensors, providing telemetry and backup. So even though radar solves for some of the certain things, cameras can solve for certain things, LiDAR can solve for certain things. It's better to look at it, how can we have multiple resilient systems? So even if one fails, another one is able to provide proper telemetry within especially a city or suburban environment.
Cool. How do you keep the data from being poisoned?
Yeah. Or security. So data security and just network security in general is going to be a major challenge. A lot of people don't have quite an appreciation of how big of a challenge this could be for the 5G networks. But we believe there's a number of standards that have already been adopted by the financial industry and the automotive industry over the years, and a lot of those can be transitioned to this platform. But it just, if you understand this, the complexities of how we use our cell phones, there are a lot of systems that are already in place that can be leveraged, enhanced, and afforded additional encryption to allow them to be securely deployed.
Thanks. All right. From the audience, we have designed a hybrid eVTOL which weighs 12,500 pounds. We plan to fly this unmanned cargo aircraft from a ground control station. How many years do you predict it may take before an aircraft of this size and type can fly autonomously?
Wow, that's a, okay, how about I don't answer that question because I want to be an optimist, but I would say if we can address the challenge of how we get a 12-pound autonomous system deployed, then I think I'm going to be far more confident on what my answer will be on the 12,000 pound. So once again, it's if we can have systems, even 12-pound systems deployed 24 hours a day, 7 days a week, and be capturing tens of thousands of missions per day, that will get the conclusive evidence of how these systems can be adopted and how we can scale up from there.
And when do you think that will happen?
The small scale?
12 pounds. Yep.
Our goal is by the end of this year to have at least a small pocket, here in Austin and one other location here in Texas, basically operating 24/7 in a very, there's a long laundry list of mitigation strategies we have in place. There's over 20 that really go to the heart of the concerns that the FAA has, the DOT, and the DOE has.
Cool. All right. What are your feelings on using synthetic data for machine learning?
Yeah, I think it has a purpose. I mean, I think especially for a lot of the ways it's been used for autonomous cars, I think there's a great purpose. But if we're talking about the challenge of getting real autonomy adopted in a city or in a suburban environment, it has to be real. And I kind of go back to the Kiva robotics. Once again, it was real systems they tested. The simulator gave them all this incredible data. As soon as they operated within a factory or in a distribution center, nothing worked. Nothing met the simulation model. So nothing beats the physical world testing, and that's why we believe it's so important to get these labs and these corridors configured and start doing the testing.
How does the autonomous system deal with loss of connection and still navigate safely?
Well, I think we've already seen really resilient systems for disconnected autonomy. The military is really pioneered with many things. DARPA already they've already done probably a dozen different systems or programs that basically have addressed with disconnected autonomy. So our core focus is on the connected autonomy, because if you can solve for a larger scale deployment of connectivity, then you can take something that's at a level 3 autonomy and actually make it a level 5 on a successful deployment within the city. And I use this as an example, as a point to point out the same industry that wants us to believe that level 5 autonomy doesn't have to be connected and the car is going to be able to answer all the questions on its own, is the same industry for the last 15 years has had the mantra of IoT, Internet of Everything, being connected to a network. And yet, when we're talking about the first time of actually having something autonomous, whether it be a large car that's 6,000 pounds or something that's even 12,000 pounds, deployed in our society, and we want to expect it to be operating on its own, I think that's looking at the model incorrectly. I mean, if we look at connectivity, there's many things that can be done today resiliently, and then we can expand to the greater capacities as we succeed with getting the data off of this.
Have you explored geofencing that does not use GPS?
There are several. worked with several companies that have ways of doing geofencing without the GPS alignment. But once again, we believe that's something that really has to be tested, and there has to be an environment that allows that to be tested at scale. So whoever asked that question, I'd love to talk to them, because I think it's an important ingredient in how all this comes together. This picture that we're looking at right now is a perfect example. As you think about low altitude, whether it be on the ground, a rover going down a sidewalk, or a small drone flying around a city, we look at the concept of navigation easements. And those navigation easements either had to be mapped out digitally using GPS or some of these other technologies and standards.
Great, thank you. And for whoever asked that question, if you do want to get connected, please use the chat. Next question. Many of the world's best and most experienced pilots are threatened by autonomy. How can those working on autonomy bring these brains into the fold and help them understand that the best autonomous systems will be encoding their collective skills and knowledge for great societal benefit?
Well, I think that's tough. I think that there's a lot to say about how pilots have grown up and the discipline. I mean, what the FAA has been able to create in the industry, that they, the safety and the risk mitigation they do is second to none. So those concerns have to be embraced, just like the concerns on the automotive side. There's a tremendous amount of people that don't believe that autonomy is going to happen in cars and trucks on the ground. I think it's all about seeing the data and seeing things really deployed. So I think if we have an honest conversation about how the testing can take place, how we can actually demonstrate data at scale, it's not going to be all of a sudden jumping to urban air mobility or even drones flying around a city. It's going to come from concrete data from all these labs, these corridors that show that resilience, and get that level of comfort because the data shows it. And even though the autonomous car companies love to say, hey, look at all the data, no crashes, what they also don't tell you is that they're impeding traffic because of it, because they're being so safe that they're actually impeding and slowing down traffic. So we have to marry both worlds together and to successfully see these deployed.
It sounds like you may have already answered this next one, but will we ever take humans out of the loop?
There's really concrete definitions of those terms, so I'm going to try to answer that. So what we believe is the human will be out of the loop, but on the loop still. And this is where we point out, we kind of showed this earlier in the screen, is in 1926, in fact, this might kind of tell it better. In 1926, an Air Commerce Act was passed. 4 years after that Air Commerce Act, the first control tower was established in Ohio. So we believe it needs to be looked at more of, if we really believe in low altitude autonomy around a city, we need to think about what is the control vehicle, what is the operation center that's going to control that, and we call it an ASOC, an autonomous system operation command center. So our goal for the state of Texas is for us to be the first state in the country to have an ASOC built and supporting the automotive industry, the trucking industry, the low altitude, rovers and drones within the city.
Great, thank you. Please keep chatting in your questions. We do have a couple more. All right, the next one is, do you have a recommendation on how to set up an off-aircraft network and tying it to various operator ecosystems?
Yeah, there's quite a few conversations and quite a few demonstrations of that type of system that's been done. I guess I'd have to get a little more information, but there's mesh networking, there's shared networks, there's like even the FAA and their complexity of systems. they treat different networks in different regions, and they can engage them in different ways at different times.
Yeah, definitely. And whoever asked that question, maybe you can provide a little bit more context if you'd like. All right, that seems to be all of the new ones we have right now.
Great.
Thank you so much, Jeffrey. We are pretty much at the end of our time here. If anyone has one last question they would like to ask, please, now is the time. Just put it in the chat and I can ask it now. All right, it looks like we have one more. Okay, yep, sorry, Bradley. So one more question for you, Jeffrey, and this was kind of on the same topic as something you were talking about earlier. If you are tracking the state space of each discrete flight vehicle, why have a human in the loop at all?
Well, human on the loop, and once again, it's the human might be monitoring maybe 100, maybe 1,000 in the future, but I think it's going to be a long time before we get to the comfort level of that. I mean, there's a reason we have air traffic control and air traffic controllers, and I think once again, data allows us to migrate to more and more flexibility and freedom of systems. But I think the human on the loop is going to be required for quite some time.
Thank you, Jeffrey. And thank you everyone for submitting your questions. That is all the time we have right now. For all participants, we will have you leave this meeting and return to the live stream where we will have a couple more speakers today. So please stay tuned. Thank you again so much. And Jeffrey, if you just want to stay a quick moment,
yeah,
we will have you stay just for, yep. Okay, everyone, please head back to the live stream to continue the day's programming. Thank you.